All right, to bring this section 9.1, introducing significance tests, to a close here, we're just going to look at one last example here that's just going to reinforce describing type 1, type 2 errors and the consequences of each of those in the context of this perfect potatoes problem. Okay, we have a potato chip producer, and its main supplier agrees that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes in the truck, it's going to send away that truckload to get another load of potatoes from the supplier. Otherwise, the entire truckload is going to be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment, and the producer will then perform a significance test using the following hypotheses. So you can see the null hypothesis again has that equal sign in it, and then the alternative hypothesis is where we either have a greater than, a less than, or it does not equal to. And in this case, it mentions that if there's more than 8% of the potatoes with blemishes, that is why we are choosing a greater than symbol here for our alternative hypothesis. Okay, take note that what the P is representing is the actual proportion of potatoes in the truckload that have blemishes. All right, so we are asked to describe what a type 1 and a type 2 error would look like in this setting. So we're just going to start with, again, I like to just generically write down what a type 1 error is. That is when we reject the null hypothesis when it's actually true, okay? Now, we want to be a little more specific in the context of this problem. If we're talking about rejecting the null hypothesis, that means we're rejecting that there's 8% with blemishes, and we would be going in favor of the alternative, which means there's actually more than 8% of the potatoes with blemishes. So what we would end up doing is we're going to send away the truckload thinking that it has too many blemishes, or too many blemished potatoes, I will say, when it would have been fine to use. Okay, so we're sending them away, saying there's too many blemished potatoes, when in all reality, it would have been completely fine for them to have used that truckload of potatoes to make potato chips. So what would be a consequence of sending away a perfectly fine truckload of potatoes? Well, a consequence would be that they have lost revenue because those would have been okay to make into potato chips. Okay, and then a type 2 error. Okay, remember, a type 2 error, generically speaking, is when we fail to reject a null hypothesis when that null hypothesis is actually false, meaning we should have rejected it, but we chose not to. Okay, now what would that be in the context of this problem? Well, that would be us not rejecting the null hypothesis, but this null hypothesis is actually false. So if the null hypothesis is false in this setting, that means that what actually was true is that there were more than 8% of the potatoes that had blemishes. So the truckload has potatoes with more than 8% blemishes, but since we didn't reject that, we make the chips anyway. Okay, that's what happened if we made a type 2 error. Now, what do you think would be a consequence if we went ahead and made potato chips from a truckload that had a lot of blemishes, or at least it was over that 8% benchmark there? Okay, one consequence could be we could have a lot of unhappy customers because they're getting these potato chips and they're not very good because they were made with blemished potatoes there. Okay, one last thing I'm just going to highlight here on the next page is when we talk about the probability of a type 1 error or a type 2 error occurring, the probability of a type 1 error occurring is actually quite simple. The probability of a type 1 error, which is when you fail to reject, which is when you rejected a null hypothesis and in reality that null hypothesis was actually true. The probability of doing that is actually just whatever your significance level is. Okay, so the probability of a type 1 error is just whatever your alpha level is. So given that the null hypothesis was true, but the probability that you rejected it anyhow is always whatever your alpha level is. In terms of what's the probability of making a type 2 error, that's a little bit more complicated and confusing. So that's something that we'll talk about at a later date. Right now, you only need to concern yourself with the probability of making a type 1 error is set at whatever the alpha level is. Okay, I believe at the bottom of this page, there are a few problems for you to try. We are not going to do this other example here that's at the bottom. So this brings section 9.1